Hi and welcome in our today's video. Today we are going to be exploring and implementing an interesting IoT project with the title Smart IoT Fire Detection and Monitoring Solution. This project you will need few sensors and of course an IoT platform and an email account to be receiving your alerts. To start with, I'm going to be demonstrating to you how the project works and then we shall be going deep into the actual implementation. Okay. Now, from my code, what happens is I have really printed some few lines just to help in debugging. For this project, we are having a smoke sensor, a flame sensor, and we are having a node MCU or what many call as ESP8266 dev board, and we having a buzzer and an LED. Okay, I want to demonstrate to you how it works, and what happens is if a flame is detected, it will print flame detected in the scripts here, and if of course the smoke is detected, it will still print smoke detected, and whenever it detects one of the parameters, the alarm rings. Okay, for instance, I'll use my light here. So as you can see, it is detecting flames. That is flame being detected, and as you can see in the auto scroll, definitely flames were detected. As you can see, these are the flames detected, and according to my value calibration, we are having some values being sent in cloud. Let me show you here on my Adafruit. According to my configuration, I have configured this value as a percentage. Now, depending on how, let me show you. So this is the flame. As you can see, the value should be dropping. Just a minute. As you can see, the value is dropping to 6. So that means we have a very high flame rate. If I just turn it off, the value should be rising very fast because there are no flames being detected. Okay. Now for the smoke sensor, I'm having two states. It's either high or low. Now I'm going to simulate this just in a few. All right. Okay. So as you can see, we are having the smoke being detected here, and of course it's being printed here. Let's see in the cloud, and we should be having value 1. Okay, now uh, another thing that I wanna be demonstrating is I want now to, of course, simulate the flame again. We expect an email alert to be sent here, of course, telling us that both aspect has been detected and things like that. Okay, yeah, the value is going down. Oops, yes, we are having emails flowing here, guys. 0 minutes ago, the smoke find has been set to one value, smoke detected, blah 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 blah. Okay, I want to now explain to you guys how this works. Let me switch my circuitry off for the purposes of just avoiding this noise here. Okay, so this value should go to 0 just in a few. Okay, now it went to 0. All right, now let me explain to you how the entire project works. This is the documentation on my GitHub. This is a repository which is publicly available, so it's a smart IoT fire detection and monitoring solution. Now, as you can see, I have demonstrated how to test your flame sensor, how to test Adafruit, and of course, how to test your smoke sensor, and of course, the final code is in this link here. Okay. Now, first thing you need to understand, of course, is the circuitry, which is very straightforward. The circuit diagram, of course, we have the flame sensor, we have the smoke sensor, we have an LED and a buzzer. We have two main sensors, that is flame sensor and a smoke sensor. Each of these sensors has got 4 pins, that is a ground pin, and an analog pin, a VCC, and a digital pin. When it comes to the flame sensor, I'm utilizing the analog pin, and I'm connecting my analog signal from the flame sensor to ESP8266 dev board, of course ground to ground, VCC to VCC. When it comes to smoke sensor, I'm using the digital pin. I have to emphasize that. So connect your digital pin from your MQ2, or it doesn't matter which version of the smoke sensor you're having, but take your digital pin to GPIO number 12. That has been also been declared in the code section. As you can see, we are having the smoke sensor to GPIO number 12. We are having the LED connected to GPIO number 15. We are having the buzzer connected to GPIO number 12, number 14. And of course, the sensor pin, which is our analog pin, has been connected to A0, which is our analog pin, as you can see here. Okay. Now, after making sure, of course, your circuitry is well done, configure your Adafruit dashboard. This is the Adafruit dashboard. The Adafruit dashboard is pretty straightforward. It's nothing complex. It's very easy also to understand, because creating an Adafruit account is usually free. And one thing you notice about Adafruit's account is very easy to manage. When you log into your Adafruit account, you notice we have the devices, we have the fins, we have dashboard, actions, and power-ups. Now, you need a few things for you to get connected. Now, when you click into the devices, you will click into this key here, and of course, you require this app key. This is the app key. Copy paste this app key and copy this username. Now, when you come to your script, which I have provided, this is the code that I have provided. Copy paste your username and paste it under username here, which is this one here. Copy your active key and paste it here. And then the other thing that you need in this code is a Wi-Fi password, that is a USSD, and also a password. I've always insisted, if you do not have an Wi-Fi, you can use your mobile phone to create a local hotspot. The local hotspot provides a SSID and a password. Now, take your SSID and of course just paste it here, and of course paste your password here. The next thing you have to do in the Adafruit account is create a feed. Now, navigate into the feed. Creating a feed is quite straightforward. Just click new and then maybe call it smoke 2. Then you can write some description and then click create. After clicking create on smoke 2, just click it. And one thing that you notice about this is it has some feed information. And the feed information, the most important thing is this feed name and the feed key. Just copy paste the feed name and just keep it somewhere. The second thing you need is create another feed, because you notice we are having two feeds, that is smoke and of course a flame. Create another feed. Come create another feed, maybe call it flame 2, and then create. And of course you just need to keep the information, that is the feed info, that is the flame 2 information. Okay, navigate to dashboard and you need to create a new dashboard. Okay, maybe call it test dash and then click create. Okay, and then navigate to test dash. Just navigate into this icon and then of course create a new block, and you want to create a line chart. Click line chart and then select your parameters. The first parameter is flame 2 and smoke 2. Okay, then click next, and you can of course give it some titles, maybe call it flame smoke. Just give it a reasonable name, and of course you can put the history you want to monitor, maybe say 1 hour, and then x-axis maybe you can name it as, you can call it time. Then y-axis maybe units. Whenever you're going to go, of course you can just create a block. Let me edit this, and its layout. I want to make this one bigger a little bit, just like that. Okay, now to create your actions or your alerts, you need to navigate into the actions subsection here. Click new action. You notice we have 3 different types of action. We have a reactive action. This is an action that is updated on real time. And then we have a scheduled action which runs at a set interval, which can be hours, days, seconds, hours, minutes, it depends on how you want to set it. And then we have a timer action which runs after find is updated on a specific time. Most of the time it is 10 seconds, otherwise every 15 minutes. Okay, for this case we want to set a reactive action. Now you just need to choose an action. Then if let's say maybe it's for the smoke, which we know very well, the value can only be 0 or 1, so is equal to, be equal to say 1. Then do what? Then email me. You can either email yourself, you can publish a webhook, you can publish a message, a lot of stuff here you can do. And then select the field value, it is smoke 2. And then this is the subject, you can edit it. It is of course embedding the field name, which is smoke 2 as a new value. This is the value. Be aware, maybe be aware, you know. And then you can edit the body. After that, of course, you need to get the notification. You can limit the time in either minutes, hours, or days, and then submit. As simple as that. If you want to create a new feed, then just click new feed, and then of course it has to be reactive for this project. Then say for this case maybe flame 2, and then is maybe less than, because for our sensor how we have configured it, any value less than 40 means the erase flame. Email me, select the field here, which happens to be flame 2, and then you can hand it your subject, maybe be aware, and then you can end it your body. It is of course embedding the feed name and taking the value of the feed, and then of course the created points. Okay, and then after that of course you need to just submit and you're good to go. That is how you create actions in Adafruit. Now remember we end our fins, we copied our flame 2 and smoke 2. Okay, now navigate into your code. Let me show you. This is my code. Okay, after navigating into your code, you notice that this code actually works with two libraries. The first library is ESP8266, and then we have Adafruit Wi-Fi library. All of these libraries I have provided links in the repository where to get them. Of course, we have the two libraries, that is Adafruit Io master and of course Adafruit HTTPS client library. After making sure you've installed the right libraries, you need to understand now how to exactly send data on Adafruit Io. To send data on Adafruit Io, you have to create two objects that allows us to send the smoke data and of course the flame data. Okay, now you need to replace your fins here. Now the first field is flame 2, the second field is smoke 2. And after you are done here, of course, if you need to understand the rest of the code, I can just explain it to you. These are the pin definition. In this session, I'm just doing the auto tune for my flame sensor. This is the minimum value and this is the maximum value. And this is the percentage mapping that I was talking about. So I'm mapping my values, the raw values, which are from 0, which can range from 0 to 10, 23 to percentage. I'm defining some integer values where I'm storing my values. So for the smoke, I'm storing it in this variable. For the flames, I'm storing it in percentage values, and then I'm defining a certain function down here, which is a delay function, to just define the interval in which I'm sending my data. So where is it? It's here. There's a function which is a delay function. I'm passing it down here, and these are my definitions which are up here. This is where you have to define the time interval, okay, for sending your data. This is in milliseconds, okay, milliseconds. And then we have the point setup. The point setup, of course, I'm defining my sensor pin as an input, and then the buzzer as an output, LED as an output, and of course the smoke sensor as an input value. And then this one is to connect to Adafruit. Have to have this io.connect, and then we have a while loop here, which when it's first time to connect to your Wi-Fi, this one always will be printing connecting to Wi-Fi until of course it connects to your valid Wi-Fi. As you can see, it's printing connecting to Wi-Fi until it connects to Wi-Fi, then it jumps into the right loop that is try to read the smoke values and of course the flame values. Okay, Now that is what we are having here. And then we have the void loop. I'm calling a function here, which is the sensors function. And in the function, what I'm doing is, of course, doing an analog range to my flame sensor and doing a digital range to my smoke sensor. I'm mapping my flame values into a percentage. That is, I'm taking the sensor value, the minimum value, the maximum value, and the output minimum and output maximum to a percentage. I'm having some few if statements, and this if statement determines what value to be, of course, printed, and of course what actuator to be on and off. Okay, simply these ones you can vary depending on your accuracy, the accuracy that you want to obtain. Remember, for the smoke sensor, it's either a 1 or a 0. So if it's 1, then print smoke detected, and then LED goes on. And then of course, if the value of the smoke sensor is 0, of course print no smoke. And of course, if the percentage value is less than 70, according to my mapping, of course, what is happening is the flames have been detected. Okay, and then we have, if the percentage is greater than, of course, 70, then no flames detected. That is what has been printed. And then we have an overall if statement. If the smoke is detected, that is, if it's high and the percentage is less than 70, then the smoke and flames are detected. It's a critical condition. If there is no smoke and there is no flames, then you are safe. Like for now, there are no smokes, and as you can see, it's printing like this is the condition being executed, that no flames detected, no smoke detected, no, and you are safe. Okay, that is what is being printed here. Pretty straightforward. The main aspect here, of course, is the interval. It defines the interval in which we are sending our data on our Adafruit account. And then we have our defined object here. We are sending our percentage, and the second one here is sending our smoke value here. So this is the smoke value and this is the fire detected. Okay, so I want to compile this and of course upload it and see what happens. We've created another dashboard here, which is test dash. So I want to see if we get our values printed in the new dashboard. Let me just compile and of course upload it. Takes a few, right? Still in. Okay, uploading it now. Okay, at 7%, 15%. Writing in the last addresses, and after done writing in the last addresses, of course we should get the data or when being sent to our new objects which we have defined in Adafruit. Right, and it's done uploading. Let's see. The first thing, of course, it has to connect to our Wi-Fi, and it should not take much time. After it has connected, of course, it is sensing no flame detected. Let's see, of course, if you will get some parameters being sent here, guys. All right, it's quite interesting, and as you can see, we having our value being sent here onto under new block, smoke 2, then click next and call it smoke 2. Then we have 0 to 1. Remember, we can only have 0 to 1 as our smoke. Then click create. Okay, then I need to really edit it to make it look nice. Then drag it here, drag it down here. Well, it's very customizable, so I need to drag it up here. Excuse me. I need to just make it neat a little bit and drag it up here. I wanna push them up here, push it up here, test board, push this one up, push this one up here, then up here, then save it. Okay, I want to, of course, see if the flame volume goes down. As you can see, it goes down and it goes down. The flame is so high, of course it drops. That is according to the mapping. I want to, of course, simulate the smoke. So I told you I can't really as you can see, that is 1, and our data is also changing here. We have 185, and things are getting more interesting, guys. Thank you so very much. I have more emails landing, guys, and I hope really this project is interesting to you and you found it very much useful. And thank you so very much for your support always. And remember to like, subscribe, and of course, share this video with your friends. Thank you so very much. Until next time, thank you.